Good morning. In this video, I will be solving integral of x squared plus 1 factor of exponential 3x. So we have a polynomial multiplied by exponential, which is a product of two functions of different type. As we have seen in previous videos, when we have a product of two functions of different types, we use integration by parts. But in the case where I have a second degree polynomial and an exponential, I have to do twice integration by parts in order to solve this integral. So another method to solve this integral is called tabular integration. And tabular integration is where we have these two functions. I'm integrating their product, f of x and g of x. We put f of x on the left, and we derive until 0. So successive derivation of f of x until reaching 0. And here, the polynomial is the function that I derive until 0. Because in all cases, the only function that is successively derived until reaching 0 is a polynomial. And on the right, we put g of x, which is in this case, it's going to be the exponential. And we write its antiderivatives, same number as the derivatives of f of x. And then we join the first to the second, second to the third, and so on. Let's see in our case what we have. So as I said, we put the polynomial on the left, which is x squared plus 1. The first derivative of x squared plus 1 is 2x, then 2, then the derivative of 2 is 0. So successive derivation until 0. Then we put e3x on the right, and we write its antiderivatives, or the integral of e3x. And I'm using this rule, if you want, to integrate e3x, because integral of ekx, where k is a scalar, it's a number, dx, it's 1 over k ekx. So the antiderivative of e3x, it's 1 over 3 e3x. Then it becomes 1 over 9, because it's 1 over 3 times 1 over 3 e3x, and then 1 over 27 e3x. Then we join the first to the second, second to the third, third to the fourth, each one with the one below it. And we put these signs, so plus, then the opposite, minus, then a plus. And what we do next is that we multiply 1/3 e3x by x squared plus 1, and we put plus before it. So it's plus 1/3 x squared plus 1 e3x, then minus 2x multiplied by 1 over 9 e3x, so minus 2x multiplied by 1 over 9 e3x, then plus 2 multiplied by 1 over 27 e3x, plus a constant c. And taking e3x into factor, we will get that our integral would be equal to 1/3 x squared plus 1 minus 2 over 9x plus 2 over 27 factor of e3x plus a constant c. Now, this method of tabular integration, we are able to use it when we have a polynomial, because the function that will give us successive derivation until 0 is a polynomial, and g of x might be an exponential, as in this case, because it's easily integrable. I can find its antiderivatives very easily. Or it can be a sine or a cosine, because also their antiderivatives are very easily found. So the second example that I will be doing is the integral, integral of two x squared, 2x plus 3 squared multiplied by cosine 2x plus 1 dx. So I have a polynomial of degree 2 here multiplied by cosine. So here we also use tabular integration because we have a polynomial which is by successive derivation will give me 0, and we have cosine which is easily integrable. So if we put the polynomial on the left, 2x plus 3 squared, if we expand it, we get 4x squared plus 12x plus 9. The first derivative would be 8x plus 12, then 8, the derivative of 8x plus 12 is 8, and then the derivative of 8 is 0. And on the right, we put cosine 2x plus 1. Its antiderivative, it's half sine 2x plus 1, because the integral of cosine ax plus b, it's 1 over a sine ax plus b. And also the antiderivative or the integral of sine ax plus b dx, it's minus 1 over a cosine ax plus b. So then the integral of half sine 2x plus 1 would be minus 1 over 4, because it's going to be half times minus half. So minus 1 over 4 cosine 2x plus 1. And then the last antiderivative would be minus 1 over 8 sine 2x plus 1. And we join the first to the second, second to third, and third to fourth, as we did in the previous example. So our integral is going to be a plus half 2x plus 3 squared sine 2x minus, then we have a minus here, so it's plus 1 over 4 8x plus 12 cosine 2x plus 1, then a plus, but it's multiplied by minus, so it's minus 8 times 1 over 8, which is 1 sine 2x plus 1. So minus sine 2x plus 1 plus a constant c. And this is our final answer.